So we are really excited that you were able to join us this morning, because we are going to tell you some very cool things that you can do with Node.js and Sheets. My name is Franziska Hinkelmann. I'm an engineer at Google in New York, and I'm a Node core contributor, and I'm also an elected member of the Node.js Technical Steering Committee. My co-presenter is Anu.
Hi, everyone. My name is Anu Srivastava. I have been an engineer at Google for over 5 years, mainly in cloud. Now, I focus on G Suite, and I own the developer experience for the G Suite editor, so that's Docs, Sheets, and Slides.
So let's get started with work less and do more, Sheets for Node developers. When you work with a sheet, your typical workflow is that you first collect the data. Then you might have to do some basic data prep, like cleaning up time zones, or maybe translate user input that you have in the sheet. Once you've cleaned up your data, you can now analyze it, which often goes hand in hand with visualizing it. Why are we talking to you about Sheets? Well, Sheets have this great advantage that you can collaborate with anybody, not just developers. Sheets basically have this universal language where anybody can edit data, enter data, read the data, sort it, filter it, play around with it, and then draw their own conclusions from a sheet. Not only can anybody work with a sheet, it's also really easy in Sheets to visualize your data in a chart. You can create all kinds of charts, of course, bar charts, column charts, pie charts, you name it. Of course, as engineers, we could be writing code using a library like D3.js that creates charts for us, but that's a lot more work. And when I need to iterate quickly, Sheets allow me to focus on the data, the trends, and the correlations instead of on the code. Because of this, Sheets is a great tool if you want to experiment and just prototype something. Probably not a production tool, but great for prototyping. If we're honest, though, entering and editing data in the sheet is not always the most enjoyable task, at least if you don't do this on a regular basis. Luckily, we can eliminate those manual parts, and we're going to show you now exactly how you can do that.
And we love Node. I hear Franzi talking all the time about how much she loves Node, how great it is. She really loves teaching people how to use Node, and she loves her work maintaining the Node core. Honestly, before I started sitting next to Franzi, I primarily coded in Java and Go, but after learning how async await works, I have been converted. So today, we're going to write a Node application to work with Sheets. So we're going to use the Node client library on the NPM registry. This has a full-fledged API for working with Sheets that we can use. This is an aside. Sheets is actually just one of the G Suite set of productivity tools. You can call these APIs for free. You don't need an enterprise account. And there's a lot of stuff in here that maybe you use every day, like Gmail, Drive, Docs. If you've been watching a lot of the talks on cloud, you might have primarily heard about GCP. But Google Cloud is both G Suite and GCP. Most of these APIs are generated the same way, so they look and feel pretty similar when you're working with them. You use the same account, they're in the same family, you enable the APIs the same way. So don't worry if you're not a Node person. We have client libraries, SDKs, in many languages, and it makes it easy to use these APIs in a canonical way. So I already mentioned Java and Go, but we have everything from PHP to Ruby, even .NET. We'll be focusing on Node today. So let's get started with a quick hello world. So we're going to be writing a script that could be running locally on maybe my laptop, my machine, and it's talking to the Sheets service to make modifications on my behalf. So we start by requiring the package. Then we initialize the Sheets client. And then right above there, we see a long string. That is the authorization scope. So the scope is the level of access we want to grant to our script. I don't know about you, but when I'm installing a new application, I get really nervous when it starts to ask for a lot of permission to my user data. You know, if it wants full access to my drive, it wants to read my emails, it wants my location history, shoe size, mother's maiden name, social security number. It is really bad practice to ask for more access to user data than you actually need. And we'll be talking about best practices for auth later today. And then also, don't worry about trying to memorize the code that we're going to show you. All of it is on GitHub, and then we will send out this link after the talk. So back to Hello World. We make our call to actually write the data. Then we need to tell the service where to insert Hello World. So in Sheets, we specify cells by what we call an A1 notation. So today, we're actually just writing to the very first cell. We're using modern syntax. And once we run that, and if we go to the browser and actually open the sheet, this is what it looks like. We wrote to that very first cell. And if you remember from that API call that we just showed, you need to specify the spreadsheet ID. Well, that ID, conveniently, is the same one you'd find in the URL if you're looking in the browser. So if you're at the point that you are using the Sheets API, you're probably going to need to write to more than just one cell at a time. And the best way to do this is to actually group your write requests together when it's possible. We have this concept called the batch update method in many G Suite APIs. And it's the best way to make modifications in bulk. So why should you group your requests together with batching? There are two main reasons. So the first is, every time any application makes a network call, there's a little bit of overhead, some latency for setting all that up and receiving it. When you group them together, you can actually reduce that total latency for all of those calls. The second is, these APIs are free to use. However, you are bound by quota restrictions. So when you group them together into a single request, you'll be using dramatically less quota. So each one of those tasks that you see, those could actually be a different type of write, and you can still group them together. So let's look at all the different things you can do. Think of batch update as a big fancy list or a bucket for all your different modifications. It's a really big hammer for many of the tasks that you can do in the UI. So we already saw that you can write data. We'll be talking a lot about adding charts today. And you can do other things, like even add developer metadata. So now that we have a basic toolkit for working with the Sheets service, let's actually try to solve a real-world problem. So I sit next to Franzi, and I frequently see her looking at the Insights tab for the Node core repo. So this is the repo that has the Node.js runtime. She is very concerned with the health of this repo. The Insights tab gives you a lot of metrics about the number of issues and pull requests over time. However, this tab only gives you insights into what's going on within GitHub. But if you've ever had a long day at work, you know that there are many different things that go into how productive we are. You can't really see things like, oh, are people being blocked by the Jenkins CI, and that's reducing the number of pull requests they could be making? You can't see if maybe they're stuck in traffic. That's why they can't close issues. There's a lot of things happening. What if just how well-fed people are dramatically affects their productivity? Franzi wants to get a holistic picture into what helps people be more productive. So let's focus in on one of those questions that we're very curious about, but that's kind of hard to define. We're going to go a little silly today, so bear with us. We want to experiment and see if we can see if food satisfaction yields better GitHub metrics. So this is a hard problem, not from a technical perspective, but a real-world perspective. We have our contributors at their machines, we have GitHub, and we have the food. We want an application to tie it all together so we can automate gathering these metrics, which is why we're going to use Sheets, so we can quickly manipulate that data. We're going to write some code in Node to monitor the Node repo. So let's get started by breaking this down.
So my theory is that we work better if we're well-fed. But we want to see the metrics. Let's look at the data to prove this. First thing we have to do is collect the data. As Anu said, we're going to get this from the GitHub repository. We're specifically interested in how many pull requests are merged, how many issues are closed, and overall, how many open issues and pull requests do we have. So how do we get this data? Well, GitHub has a very nice REST API, and if we use OctoKit, the GitHub REST API client for JavaScript, it's very easy to get this data. And the API gives us exactly the same data that we would get in the Insights tab. So it's really just a few very straightforward API calls to get this data programmatically. And once we have the data from GitHub, we will write it to a spreadsheet. So just like in the Hello World example where we wrote Hello World, now we're writing the numbers that we got from GitHub. Of course, I could have console logged the results from GitHub, copied that, and then manually pasted it into a spreadsheet. But that's manual. I might be making mistakes. I don't want to do it, so I'm using an API call. Now on to the food part. We love metrics and surveys, so we did a survey. In this survey, we figure out how happy the contributors are with their food on a daily basis. Super scientific. Every time you use a Google form, the results are automatically written to a spreadsheet. So here we just configure the form to use the same spreadsheet that we also use for our write calls of the GitHub data. All right, now that we have the data both for GitHub and for food, now we are interested in whether there are any correlations. If we are hungry, do we close more issues because we want to get done and leave to get food? Or if we had too much food, are we much slower and we don't merge any pull requests? Or if we're hungry, maybe we just open issue after issue. How can we see these correlations? Well, a quick way is with a chart. So let's do that. Here's the chart. We'll look at the results later. For now, we're just interested in how we get this chart. Of course, you can go to the sheet, highlight it, and then click Add Chart. But we don't want to do this manually, so we will use an API call. Let's see what the code for this looks like. So if we want to create a chart, we have to create an add chart request. This add chart request has a chart, and we have to pass in the specification for the chart. Once we've built our request, then we're using our friend badge update to send this add chart request. A few chart parameters I want to point out here. One thing you have to specify is the type. So we are creating a line chart. Then you need the domain. The domain is your x-axis. So in our case, it's the date. We want to see how are the trends changing over time, so we put the date as the domain. And then probably the most important part of a chart is the series, the data series. So in our case, the numbers we got from GitHub, how many issues and pull requests. So our architecture overall looks like this. So we have two data sources. We pull the data, and we write it to a spreadsheet. And then the sheet creates a chart for us. And we're doing all of this locally. We're not opening a sheet and run anything inside the sheet. All this Node code runs on our machine. We can control the Node version that we're running, and it's just interacting with the REST API. And Anu is now going to take this one step further.
Woohoo, yeah. So we're gathering the data, and we're getting insights. However, it's only running locally on a machine, so only one team member has access to it. We should really host this as a service. We are in the cloud track, after all. So ideally, this would be a fully fledged app with a client and a server. But we actually know that it's really not just those two parts. If you want to get all those good principles that we have in cloud, like high availability, fault tolerance, we probably need to add multiple servers. When you have multiple servers, you probably need a load balancer to distribute those requests. Maybe you need a cache somewhere. There's a lot of different pieces that you need to set up to have a real server. Franzi and I only want to focus on our code, not the infrastructure. So we decide to go investigate other options. This is how we land on serverless in GCP. So with serverless, you just get to upload your code, and then the cloud provider figures out how to place and scale it on your behalf. We don't need to know, or even really want to know, anything about the machines that our code is running on. And you only have to pay for the time that your code is running. So this is really great because To do a fetch of all the data and produce a chart, it doesn't take more than a few minutes. But if we were to put this on a VM, we'd probably be paying for that to just sit there idly 24/7. Then open over there just means that you get to use the tools and the frameworks and the languages that you're already familiar with. Since we're working with Node today, we're going to be using the Express framework. If you're working with Python, you'd be using Flask and all of those good pairs. So there's a few different products in the serverless family. We decided to go with Cloud Functions. So Cloud Functions, in a nutshell, they are narrow, focused bits of code that you upload to Google, and then you trigger them by events. So we have background events that they respond to some of your other cloud services. You can think of them as like glue for connecting all these pieces. Maybe you trigger an event by uploading some files to your GCS bucket. Maybe you're listening to incoming pub/sub messages. We're actually going to be working with HTTP functions today. Those are more common, and they are triggered by what you'd probably expect, HTTP requests. They're really good for things where you need to either process data like us, or maybe you're calling external services. So in the real world, people use them for things like, OK, I want to do credit card payments, so maybe I'm talking to Stripe. Maybe I want to send text messages, so I'll be using Twilio. Let's look at a quick hello world for HTTP functions. So I keep saying the word function. Is that really what I mean? Yes, with 2 lines of code, you have a fully operational backend. After you deploy this, you don't need any additional configuration like a gateway. With Google Cloud Functions, you get a fully provisioned endpoint on a fully qualified domain, and this handles the SSL certs for you. And we mentioned the framework. So those request and response objects, those are from the Express framework. So now that we know a little bit about Cloud Functions, we're going to keep that code that we had in our first version. We're just going to wrap it up in our local script and then deploy it so we have a serverless backend for our system. This service will read our data from our external sources and then produce a chart, all while running in a data center somewhere in the cloud. So we upload the code that we already have together with an exported function. We'll call it GitHub chart. And then that calls our main logic. So after all that processing is done, we send a 200 status code, just like in Hello World. And then here, we're going to send back the ID of the spreadsheet, which has our chart. So how do we deploy this function? That sounds like it might be hard or scary. It's actually really easy. You can use the gcloud CLI. The gcloud CLI is a tool that you can use to manage all your GCP tasks. So with functions, you just have to pass in the name of your exported function. So that's why we see GitHub chart again. So it uploads your code. It picks up your package.json, not the Node modules themselves. So this is really nice if you have slow data connections. It's just picking up your source code, and then it built it in the cloud for you. We can also edit and deploy the function straight from the Cloud Console as well. The Cloud Console is the web interface where you manage your cloud services, and then you turn on APIs and look at all your monitoring and stuff like that. So the code is in the cloud, but it still needs to be triggered manually by a human. We want to keep pulling in this data regularly and keep tracking our productivity over time. So instead of needing a person to trigger this function every day, we can actually schedule the function by using Cloud Scheduler. In my opinion, Cloud Scheduler is just big, fancy cron in the cloud. We set up this cron job in the Cloud Console as well. You use the same syntax as if you were using basic cron. We have ours set to run every morning at 9 a.m. And then down at the bottom, we specify that HTTP URL we got back from Cloud Functions. So now we have a backend job to do all of our data collection. And Franzi is going to take you through adding a client.
So when we trigger an HTTP endpoint, our code is run on a function. But for more functionality, it would be nice if we had a front-end client so we don't have to memorize a bunch of HTTP endpoints. So we add a client that sends out emails to the team with the new chart. And since we're dealing with emails, we're going to use the Gmail API for this task. Let's look at our front-end code for this. So just like in the backend with Node.js, we have client libraries on the front end. And then for Gmail, if you want to send an email, it's really straightforward. Gmail.users.messages.sent. You have to include your raw email here. That's just base64 encoded of your content, which could be plain text or HTML. So now we have the front end or a cron job triggering the cloud function, which pulls in new data and creates a chart. And when that is done, then the front end will send out an email with this new chart to everybody on the team. Is that the whole story, though? Just kidding. We left out auth. Authorization. You don't want others to send out emails on your behalf, and you don't want anybody to read and write your spreadsheets. So let's have a look how we do authorization in our application. In the front end, we have an authorize or logging button that triggers the Google sign-in flow. Google Sign-in is a secure authentication system that allows users to log in with their Google account that they already have. And then they can authorize your app to use Google services like Gmail on behalf of them in a secure manner. Google uses the OAuth 2 protocol. So the way this works is your application asks for user consent, like you just saw, and only then it can access user data. So the key point here is that your application with OAuth 2 does never ask for the user's credentials. It only gets consent to then access user data on behalf of the user. So remember, OAuth 2, it's consent instead of credentials. Let's look at how the protocol works in detail. This authorization flow is also called three-legged OAuth. The entities are your JavaScript frontend, the Google servers, and the end user that's consenting. So when you want to access user data, you first send a request to the Google Auth server, and then the end user has to log in and consent. If they did that successfully, then you get a token from the Auth server, and now you can use this token for all your requests to the Google APIs like Gmail to send emails on behalf of that end user. Luckily, the client libraries handle this for us, so we don't have to worry about the implementation details of three-legged OAuth. One thing that you have to specify when you initialize the client, the Google APIs client, is the scopes. And Nu already mentioned them earlier for Sheets. So now we're using the Gmail.send scope. So that means when you request the Gmail.send scope, when the user goes through the Google sign-in, then it actually says, do you allow this app to send emails on your behalf? And if users approve that, the token that we get back from the OAuth server is only good for this scope. If I take this token now and I'm like, oh, I'm going to touch your Sheets, then I get a 4.3, because that's not what the user consented to. Obviously, you always want to keep the scope as restrictive as possible. There's lots of different scopes. Definitely have a look at them if you're working with the Google APIs. I want to quickly point out this one scope, drive.file. This is really nice because instead of granting access to all your sheets, for example, you're only granting permission to the app to touch the sheets that the app itself created, or maybe explicitly was given permission. So this is a good one because users don't have to worry that your app can read all their documents. All right, so in the front end, we have a login button, and then this consent screen pops up, and the end user has to click so that you can access, that you can send emails on behalf of the users. How are we handling auth in our backend? We decided that our backend, so the part where the cloud function talks to the Google Sheet, will not have any end users involved. Instead, we have that the sheet belongs to the application. So our backend is not accessing a news sheet or my sheet. It's accessing a sheet that actually belongs to this application, and we're doing server-to-server authorization here. Heads up, though, if you're working with the G Suite API, best practice is that you should work with user with user credentials and three-legged OAuth. Usually, you don't want the documents to belong to the application. So in the backend, we have two-legged OAuth. We have two entities. We have the backend of your application and the Google servers. There's no end user involved here. And server-to-server authentication uses JSON Web Tokens, JWTs, to request a token from the Google Auth server. And then it can use that token to access the Google APIs, but this time on behalf of the application, not on behalf of somebody else. Again, here, use the client libraries. They wrap this workflow for you, so you don't have to create and sign your own JSON Web Token. Comparing three-legged and two-legged OAuth. So three-legged OAuth is always on behalf of an end user, and it requires consent from this end user. And for G Suite APIs, best practice is to use three-legged OAuth. Two-legged OAuth, on the other hand, is server-to-server authorization. And the requests are made on behalf of the application, and the resources belong to the application, not your end users. And under the hood, two-legged OAuth is using JSON Web Tokens.
Thank you for that really detailed comparison about the different types of auth. So like Francie said, this is all handled for you by our client libraries if you choose to use them. If you look at the quick starts in our documentation, they actually show you how to get set up with this in just a few steps. It's really important to use OAuth because now you're working with tokens, not people's actual passwords. We don't want people storing them, especially not in plain text. So now that we have all that set up, what's the whole point of writing this application? It was to see if we can get insights into if food satisfaction boosts our GitHub productivity. So let's look at some of those charts more closely. We made a lot of charts with our sample data that we were running through April. We can see a bit of a correlation. So this chart has all the different metrics that we were tracking. The left-hand side has the scale of the number of issues, open issues, so that's in the hundreds. But then on the right-hand side, we have the scale of the PRs and our food satisfaction. So if you remember that survey, it was from 1 to 5. Let's look at some more charts that break this down a little bit further. So if we look at pull requests specifically, looks like we merge PRs when we're better fed. Again, these line charts show trends a lot more quickly than if you're trying to look at these numbers in your console. So especially this one. I like this one because it shows closed issues and merged PRs. Those are like our completed tasks. So after we write this code, we never have to manually open Sheets again to get our insights. Now that we have this data, we could easily add data from more sources. Say we could actually get traffic, commute times, more realistically, things that you probably already have, maybe some other internal systems that you're using, application monitoring, other APIs that you have around. You know how to add stuff into Sheets. So in conclusion, good food yields good code. And now we have the data to back it up if anybody wants the proof. We're going to tack on one last thing to our system. So another workflow that we see a lot is people having to create reports regularly of data just like this, maybe for their managers or team meetings that you frequently have. And I don't know too many people who are really jazzed about making reports. So let's see if we can do some automation. So yeah, these reports, you might have to make them weekly, monthly, quarterly. Maybe you know some salespeople who make these types of reports for their clients. They could be in a slide deck. They could be in a Google Doc. Maybe we just want to prove our good food trend over time. So we share this info with people all across the company in a doc that's quickly easy to look at. So maybe you specifically don't have to do this, but maybe you probably know someone who does. And you can make them really happy by scripting this as well. So let's look at a sample report and then see how we can automate this with the APIs that we're already using. If you've ever had to do this sort of thing yourself, maybe the first thing you do is create a copy of an old one, and then you start manually updating that data. This can be super tedious. It can be really error-prone. It's easy to miss pieces of data that you need to update. And then, well, what if you use a template? Templates are pretty common, but you still have to do some manual work. So we're going to completely automate this. You can use the Drive API to make a copy for you, and then we'll use slides to actually merge in all that data. We'll look at some of the pieces of data that we want to update. For example, on our first slide, we have the report generated date. So we're going to create a slides API client. The syntax should look really familiar. And then that date that we saw on that first slide, we can actually make a replace all text request to update it with today's date. And you guessed it, replace all text is a type of batch update. And we can do this for other text placeholders. You can replace any sort of text. I just happen to use all caps with curly brackets, so I know what are placeholders. But maybe we had a slide summarizing the total number of pull requests and issues. So now let's look at how to add our charts that we made. What's really nice about these APIs is that they're tightly coupled together the same way that the products are. So Slides has a method called createSheetsChart. And you can get the sheet or the chart by its chart ID, which you can get via the Sheets API. And then if you write a script with all of these different code snippets, you can completely automate generating a report with no human intervention. This could save you or your coworkers hours and hours of time. So now that we've added reporting, let's take a step back and look at the system that we designed today. We designed a basic reporting system using Node and our G Suite and GCP APIs. So our front end triggers a cloud function that fetches data from external sources and creates a chart. Now we have multiple ways of sharing this information, either via email or a report. At its core, we're using Sheets as a data manipulation and collection tool. So our experimental app investigates if lunch affects our productivity. We know this probably isn't exactly what you or your company needs right now. You probably already have dashboards and analytics, but what we really wanted to do was inspire you to be creative and think of maybe some non-technical problems and solve it with the tools that you are probably already using every day. We really hope you have fun coding on your next project with Node.js. Our completed code is on GitHub, so feel free to tweet at us and let us know what you think. Thank you, everyone, for tuning in on the live stream. And for everyone here today, we would love to answer your questions right outside. We look forward to meeting you and have a great time with the rest of I/O.
Thank you.